Okay, so how many hours are there in a day? 24, yeah. And actually down here, I'm going to hopefully go to this website, and there used to be, the days used to be even shorter. So how do we know it's a day? How do we demark it's a day? Right, the sun sets and rises again. That's one day. And all this is telling you, and it's kind of a subtle thing, but I decided to leave it in my notes, is that we call the time it takes for the sun to rise and the sun to set one time, to go through one, is that right? A day is where it rises and then it rises again. Yes, it rises and then it rises again, yeah. So the deal is that, I'm going to go ahead and make this the sun again. Is that since if this is daytime, right? Okay, this is nighttime. I'm at nighttime. Okay, and I'm at daytime again, right? Okay. So the thing is, though, is that the Earth is moving a little bit. Okay. So the fact that the Earth is moving, what direction are we moving around the sun? Counterclockwise, exactly. The fact that the Earth does this a little bit means that I have to go a little bit further. Exactly, to get to the sun again, exactly. So we call the sidereal rotation, that's actually only it's short 4 minutes from being 24 hours. Okay, the extra 4 minutes that we call 24 hours is actually this little bit to kind of finish the deal. Okay, and we call that synodic or synodic day. Okay, so that's kind of how that goes. And this actually, see if this will take me out. Yeah. So some of you guys have kind of watched those documentaries where it kind of talked about the situation of the Earth a long time ago, you know, when the Earth was first formed, and we'll be talking kind of about that too. But the Earth used to spin a lot faster, okay, than it does now. But actually, even since 1960 to the current day, the Earth is slowing down. Okay, so as the Earth slows down, we get a little bit more time in our. And I think it's a conservation thing. If you kind of go back to the physics of it, we're losing a little bit of energy, so we're slowing down.
So it's like we're losing.
If the Earth spun faster, would gravity feel lighter?
If the Earth spun faster, if it spun faster like all at once, that would actually make some interesting forces with regard to gravity, I would think. But gravity is more a function of the mass and not the spin. The spin gives us this momentum, kind of.
To keep it or no?
Yeah, and it needs to be conserved. Yeah.
So if it gets too slow, are they going to wrap a big string around it and tug on it and make it spin fast again?
I don't know. There's actually a movie called The Core where they go in and they monkey with the core of the Earth.
They detonate nukes and make it spin.
Yeah, and they get the nukes to make it, to fix what they broke. So, I'm not quite sure about that. Okay. Let's go back. No. This should go back. Okay, so that's one topic. How long is a day? Now, the next topic we need to talk about is one that we left off on Friday. Why do we have seasons? Okay, so I'm going to remind you, if this is the sun, that's Polaris. I'm going to go ahead and grab my axis of rotation, and I'm going to tilt my axis of rotation towards Polaris, okay? And you guys told me this is a year if I go one orbit around the sun, so I'm going to go like this, okay? This is 3 months, right, from where I started. This is 6 months. And we talked about how in the Northern Hemisphere, is this summer or winter? It is winter, very good, okay? And this is spring coming up, okay? And this is summer in the Northern Hemisphere. Of course, the Southern Hemisphere has opposite seasons as we do, okay? And we talked about daylight hours are different, okay? So here in the summer, the Northern Hemisphere has the most daylight hours, Southern Hemisphere, especially if you're south of that special 66.5 degrees latitude in the Southern Hemisphere, you don't have any, daylight, okay? So there's also an angle thing going on. Let me see if I can. Now, have you noticed this figure right here, okay? If I was to ask you, we're kind of leaving December, does the sun seem low on the horizon in December? That's December right there. The sun crosses the sky, but it's low. Mm-hmm. Yes, it's low. We have shorter hours of daylight, okay, but it never gets very high in the sky. Yep, so we're just kind of leaving that. Now if we could watch the sun, day after day, I have a picture coming up, okay? The sun is now getting higher in the sky. Up here, this would be our summer solstice. What day is the summer solstice on? Yes, June 21st. Very good. So that's June 21st. And then what about the solstice down here? What a winter solstice? December 21st. Yeah, 22nd. I can't remember. Okay. So this is actually just kind of showing you how high up the sun gets or how low the sun gets. And angles have consequences. So let's see. You guys told me this is summer. Okay. So over here, the sun is highest in the sky. And anything, well, if a light like that is high in the sky, okay, we actually get the beam of light to scatter or to spread on the smallest place possible if it's got what we call a big angle with the horizon. Okay, big angle with the horizon, that shaft of light is only spread over that much. Okay? Now when the sun is kind of low on the horizon, like over here, okay, in the winter, when the sun doesn't rise very big, okay, very high, basically even at noon, that shaft of light has to hit our location and it's spread just like this is showing. Can you kind of see the area of A versus the area of the left one and the right one? Okay, the right one here is when the sun is low and the first one is when the sun is high. So it doesn't look like much of a consequence, but does it look like area of A is less than area of B? Okay, so it's more concentrated the more higher up the sun is. And actually, when I taught this in meteorology, when's the hottest part of the day in the summertime?
Afternoon.
See, you could say noon because the sun's rays are most direct, but you could say there's a lag till about 2 or 3 p.m. Yeah, so you're kind of both right. But that's the other thing. And the last thing I need to talk about, and it's an angle thing, is this. Let's see. This works. Okay, can you guys see? It's kind of small. See down here? Okay, there's actually, I'll get my pen. There's actually 2 kind of bars on there. One is where the sun is kind of directly overhead, right here. I'll call that A. Can't see that very good, can you? I'll call that A. Okay. It's really small, sorry. But what I want you to draw your attention to is, do you see this right here? This is the amount, that little fuzzy blue thing, that's the Earth's atmosphere. You can't see it? No. Okay. Well, can you see it right here? No, look up here.
Oh, sorry.
Okay. Okay. Can you see that? That little bar, that's the Earth's atmosphere. Okay. And that's when the sun is nice, it has a big angle with the horizon. Compare that to this one down here. I'll call that B. Okay. And again, what I'm trying to draw your attention to is the sun's rays going through the fuzzy part of the Earth's atmosphere. What would you say about B? Yeah, it goes through more of the atmosphere down here. B is more.
Much more FPS.
What's that?
Much more FPS.
Much more FBS?
The sunscreen.
Oh, yes, exactly. We need more sunscreen at location A than we do at B. Because actually, the Earth's atmosphere kind of does a good job of knocking out some of that harmful radiation that we use sunscreen for.
Earth needs more sunscreen there, too.
I'm just trying to picture somebody lathering on sunscreen. Okay.
Is it because it's not directly onto it?
Right.
Making it go through the
Yep.
part of it?
Yep, it's because it's not directly onto it, it's coming at a slant is the way I think of it. And it kind of skims across more of the Earth's atmosphere. Okay, so, these seem like extremes and all that, but let me tell you one thing that just happens through the course of the day. Let's just go back to normal sun rising in the east, and sun setting in the west. Okay, when it rises, when the sun rises, is that a small angle or a big angle it's making? No, small. That's a small angle. What's the biggest angle it can make? I think 90, because then after that, you're starting to get small again. As it starts to, goes to noon, it gets smaller like that, okay? So those small angles has the same consequence. When it's small, don't you feel like even if the sun is shining on you in the morning, when it's a small angle, yeah, it's not as intense.
You need a jacket, and then after
Yeah.
you take your jacket off.
Exactly. Exactly. You need a jacket because the sun's rays are spread like we're seeing here, and also they have to go through more of the Earth's atmosphere. Okay? So that's kind of how that works. Even on a daily basis, let alone a yearly basis. So they both are going at the same time. Okay. So that was the seasons. And we talked about this a little bit. Do you guys remember, is the sun in the center of the Earth's orbit? No. Mm-mm. It is on a foci. It's off center. The sun is off center from the Earth's orbit, exactly. Do you remember the term, let's see, when is the sun closest to when is the Earth closest to the sun? How many people think it's in January? How many people think it's in July? How many people think it's in January?
I think it's January.
You're right. It is January.
Why was it again?
It's just because the sun is kind of off center, and it's in January that we're actually, and I think on here, it's this one right here. Well, that says the December solstice. So a little bit past the December solstice, we have January 4th, and this distance is smaller, okay, than this distance. I know.
We're cold then.
I
So
know.
it makes our brains want to think, oh my,
Yeah.
I can't be comfortable.
I agree. So as I've been talking about this, you guys told me this is winter in the northern hemisphere. So go a little bit further, January 4th, and that's actually when we're closest. And then we're farthest over here. Do you remember the name we call close and far? Starts with P and A. It is perigee and apogee. Very good.
But just how far,
Perigee.
how much closer are we to January?
I think this slide says, if you can read it, and it's in your textbook. Or maybe I have it coming up. I don't know, maybe it's coming up. And this is larger. And this is called apogee. I mean, it's like kilometers of, it seems significant. And I've seen a percentage. Is it 4%? I don't know. Farther or closer, yeah. So I don't know if we'll come back to that or not, but. Another thing we need to talk about, okay. So what is this stick? What does it represent? Yardstick, yeah, the axis of rotation. And where does it point? Towards Polaris, exactly. So we have this kind of thing, and the Earth orbits the sun. What is this angle of tilt? Do you remember?
23.
Yep, 23.5 degrees. Okay. So the deal is, though, is that historically, it stayed tilted like that. So see if you can see me. I'll try to keep it tilted like that. But it is pointed at a different pole star. Different pole star, different pole star. It took about, I think, does the slide say, 26,000 years to come back to the same pole star. And that's a long, so if it's that many years, you know that the Earth is orbiting the sun all that time. It just points to a different pole star. Okay.
Oh, that's good.
I know. And so it makes kind of a cone in the sky. I think that is so cool.
So it won't always have Polaris then?
Right?
Yeah, that's what I was trying to wrap my brain around.
Yeah.
Like, what would be the one before that then, or after?
Well,
that?
this talks about, this used to be my daughter's favorite star, a star called Vega. It's in the Lyre, the constellation Lyra, the Lyre, Vega. And so it used to be close to that. But one way to think about it, I had just not thought about this, but what if the southern hemisphere finally gets a south pole star somewhere in there? Maybe it's their turn, the outback can be heavy. So, now the reason it does it is because of kind of, this talks about gravity. I'm trying to think, is it the moon? No, I guess not. It's just kind of a little bit topsy-turvy, kind of like a top is spinning on its axis, like the Earth is spinning on its axis, but kind of near the end of the top doing its thing, it kind of starts to kind of wobble. And that's what we got going on. Precession. Okay, there we go. I thought about getting, and Logan's not here, I thought about getting the sun and the moon and the Earth back up here to kind of show these things, but I'll just kind of do my best. Okay. So it takes, let's see, 7 times 4 is 28, 4. So about 4 weeks, okay? About 4 weeks for the moon to do its thing. The reason I like 4 weeks is you can divide it into fourths, and you got 1 week, 2 weeks, 3 weeks, 4 weeks. Okay, so 29 and a half days. For the moon to orbit the sun one time. Oh, wait a minute, does the moon orbit the sun? No, not really. For the moon to orbit the Earth one time, okay? And the moon is also spinning on its axis, and it takes the same amount of time to do that, okay? 29 and a half days to spin on its axis and orbit the Earth once. It's called synchronous rotation, and I have a slide coming up to talk about why that means we only see the same side of the moon.
This is the hard.
Yeah, I think I'll wait for the slide coming up. What else do we need to know about the moon? Well, just like we have, yeah.
I like this one. I saw it.
Oh, I was calling those. Just like we have the perigee being closest, the Earth being closest to the sun, and apogee when it's furthest from the sun. Also, we have the moon closest to the Earth at perigee and furthest from the Earth at apogee.
And this wasn't that long ago, was it?
The supermoon,
Yeah.
yeah. I think
got to see it.
we had full moons that were super full moons. I think in November and December. I think, yeah, the supermoon.
It was so bright. It felt like I saw it at night.
Yeah.
Yeah, it seemed big, didn't it? Yep. Super duper. And then just to double check, make sure we're all on the same page. The moon doesn't have any interior energy that it's creating, so it doesn't glow of itself. If the moon were to kind of gravity, the Earth let loose of it, and it roamed the universe, it wouldn't glow at all. The moon wouldn't. Yeah, it only glows because the sun's light hits it and shines in all directions, and then we see that.
Oh,
Yep.
that'd be sad without
It would be.
like it'd be there and it wouldn't be bright.
It would be. So, one of the things we need to do today is talk about lunar phases like full moon, new moon, the quarter moons, okay, crescents and gibbuses and all that. And here kind of you get a precursor of what that's going to look like. This figure down here. So you see the sunlight hitting the moon. Now how much of the moon gets lit up all the time? Half, exactly. Half, 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 half. Oops. Going counterclockwise. Half, 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 right. Okay? And, you know, students, we do pretty well with this. Does this make sense that if this is the sun, as I've drawn it up here, okay, do you see where we're seeing the full half right there? Okay, we call that a full moon. Okay. And then do you see this one right here? I guess I better go counterclockwise. Okay, it's going to go counterclockwise. Okay. Does this make sense that the amount of the moon that we see actually is a half of the half?
Yep.
Yep, we call that a quarter moon. I'll put Q for that one. How about right here? If the lit part's over here, how much of the lit part are we going to see? None. What's the name of that one? New. Very good. Okay. And then over here, what do we got? Another quarter. Okay. So that's kind of how it goes. It goes counterclockwise.
New moon one more time.
What's that?
Can you explain the new moon one?
The new moon? Yeah. So the new moon over here Now you figure, you guys told me that half of the moon is lit up. So, like if this is the sun, I'll kind of try to do it. If this is the sun, I don't want to do that. Okay, if this is the sun and I am the earth, okay, and I'm holding out, what I'm holding out here is the moon, okay? So this part's lit up, but I just see the dark part. So it's not lit up at all, it doesn't glow. So it's a new.
So it's not getting enough sunlight, or?
It's getting the same amount of sunlight, I just can't see the lit portion.
It's like when you got a flashlight on your back, you can't see the person's face.
Yeah, I think so. She says it's like if you have a flashlight on someone's back, you can't see their face. That's what she said.
Yeah.
Yeah, yeah.
Okay.
Like their back is lit up, but their front, which is towards me, is not lit up at all. Because you guys told me over here is a full moon, right? Because basically light hits the moon and it's reflected back and we see the whole circle.
Right.
Okay? And then right here, we can actually only see a quarter. And here, we can only see a quarter.
By the sunlight?
What's that?
It's because of the direct sunlight that you only see that much?
It's because of the what?
The sunlight?
Yeah, it's because of how much, because the sunlight has to hit the moon and come back to us. And like here, the sunlight's hitting the front, but like Lindsay said, we don't see the back because it's not lit up. Yeah.
Okay, so the sun is big enough to light it through the earth, like, you know what I'm saying? Not literally through it, but.
It's not,
Never mind.
well, keep working it.
Cause it's interesting that, like, the sun on the back, you can't see the front, but on the other side, if you think of it, and the sun's still over here, and the moon's on this side, and the light still goes through, see what I'm saying?
I think so.
Like, if you turn around and your moon is on that side, but the sun's behind you,
Right.
the light's big enough that it gets past. That's what I'm
Right.
saying, that's what's confusing.
And we're gonna, yes, and
Sorry.
actually, you're
I didn't know how to
right
word
on the
it.
right track because, one of the things we'll talk about is
Yeah,
eclipses.
yeah.
Is
Yeah,
eclipses.
I was following you, sorry.
And actually, the moon is kind of bobbed a little bit out of being in a straight line with the sun and the earth. It's about a 5-degree slant out. And so that's actually helps explain that. And actually, also over here, the moon is kind of bobbed out a little bit from blocking the sun. Yeah, but sometimes it's not. And we get a solar eclipse over here, and sometimes we get an eclipse of the moon over here. Very good, very good. It's all good. Okay, so the coolest part of looking at the moon through a telescope is the terminator. I couldn't resist. So, like for instance, if this is a quarter moon right here, you guys would tell me the lit portion is over here, and the dark portion is over here. Where the lit and the dark meet is the terminator. Okay, so. Yeah. So I think this figure's pretty good. It kind of talks about what we've been talking about. The way you look at this figure is you can see the sun's kind of coming from a different direction. So here we have the sun over here. And so here, she is the earth. I'll put E for earth. She's the earth. So you can see right here, that is our new moon, for instance. Okay. Now, again, it has to kind of be bobbed out a little bit from directly being in line with the earth and the moon and the sun, because if it wasn't, it would block out the sun from the earth's perspective, and that gives us a solar eclipse. Okay, and then here we have our quarter over here. Notice she has it moving counterclockwise around her. This is where half of it's lit up, but, sorry, bless you. Where a full part of it's lit up, but we only see 1/4 towards us. And we'll kind of go over here. This is the full moon. And then over there, we have kind of behind her is our other quarter. Now we call this the first quarter. I get this mixed up sometimes. We call this the first quarter and this the third quarter. I don't know. Sometimes I call it the first quarter and the last quarter because I just, kind of drives me nuts. What's the difference? What's the difference in if you just look at the quarters, can you tell the difference, which quarter is which? How could you tell which quarter is which? What's different about them? They're shining on a different side, exactly. And sometimes the way I remember it is it kind of goes from right back to left again. So actually what we call the kind of the lit part is getting more and more from the right back to left again. See how it's getting more compared to here? And then over here, I see that actually it's dark going from right back to left again. So it's getting less and less illuminated. That's how I think of it. Very good. So, do you guys buy this? Who has seen the moon in the daytime? Yeah. Seen the moon in the daytime. Is that not weird or what? Yeah. What's up with that? But it kind of makes sense though, because if this is the sun again and I am the earth, you figure if it just passed new, okay, so it's on its way to do a 29.5-day circle around the earth. If it's just a little past new, it's going to be near the sun. And you can't see things that are too close to the sun, but you give it a few days, and by golly, there's the sun and there's the moon, okay? And one of the things I like about going with 28 days, even though it's 29.5, is you figure it takes a week to go from here to here, it takes a week, and it takes a week to go from here to here, and it takes a week to go from here to here, and it takes another week to come back full circle again. So that's kind of how I think. A week between the major phases. Okay. Right. So, you're going to want to know are there 8 here? Okay, the ones that we talked about were new. Okay, we talked about new, first quarter, full, and last quarter. Now, the ones in between, we use the word crescent, as you can see here. We use the word crescent if it's a sliver. Crescent means it's a sliver. So actually, as it's just leaving new, going on its way to first quarter, it's building up from a crescent to a first quarter. Okay, so I hope that makes sense. If it's building up, we use the term waxing. Okay, so that's a waxing crescent. Yeah. And then, if it's more than a quarter, we call it a gibbous. Like if it's more than a half a moon, and here's where my husband's like, now how come they call it a full moon? It's full moon. Why don't they call it a half a moon when it's a half a moon? You know what I mean? It just seems, anyway, I don't answer him. So notice here, it's actually past first quarter on its way to full moon, but not quite full moon. So it's past, it's not a sliver by any means, it's past a quarter. And it's continuing to increase, so we call it waxing. So actually from here to full moon is going to be waxing. So we're going to have a waxing crescent, quarter, waxing gibbous, full. Okay?
So it's past a quarter?
Yes, it's past a quarter. Yep, gibbous is past a quarter. And then once it's full, it's on its way to be in a new moon. So once it's full, it's not going to get any fuller. So we actually then say it becomes a waning. Waning, yep. Waning means getting smaller. So the first stop, though, is a waning gibbous, because you figure it was beyond quarter. It's going to stay beyond quarter until it gets over here. Okay?
Such a weird word.
It is a weird word. And then here, it's going to go ahead and continue to wane from a quarter to a new, but now it's going to be a crescent, so it's a waning crescent. So that's kind of how that goes. So those are the terms you're going to need to kind of know. Okay? Yeah, I think those are fun. And here's where I have just a few photos of mine. Kind of look for the, what's that?
You took that?
I did. This is through the telescope. I know.
That's so cool.
That's beautiful. I'm sorry, but I think it is.
How did you get it?
And I bought a new focuser. You know, what's that?
That's so cool. I got to get that.
And remember, we're going to kind of play around with your smartphones this semester, see if you can get some pictures out from your smartphones. But even forget the telescope, just are taking the photos.
Is this a waning moon?
Yes, this looks to me like a waning moon. I agree.
It's got a texture to it.
Yeah.
I've never seen
It does.
moon with texture.
It does. And what I started to say is you'll be able to see, I mean, this is what you'll see in the telescope. I just love the moon. That's beautiful.
Oh.
Yep.
So That's a full moon.
That looks almost full, doesn't it? You can kind of see that up there.
Looks like it just got into a fire.
So is that still waning?
If it kind of looks like it. Kind of looks like if this is the right orientation, I pause because sometimes through the telescope it flips the image around. So I can't remember if these are flipped or not, but I think they're correct.
What's the little like, they look like suns almost on it? Is that where they can hit it?
That's where things have hit it. Yeah, these are impact craters.
Oh, okay.
Yep. And the more, I think this is right, the more whitish it is, the more recent it is. And what I think is cool is, can you kind of see does it kind of look like it?
Yeah.
Yeah.
Yeah, that's where civilizations used to live.
No. You can see kind of this one. Now this is neat up here. Can you kind of see that's got kind of actually built up kind of high. It's got a big crater in the middle and kind of, yeah. I just think it's cool. I know. Okay, so this looks overexposed. And I don't have a slide to show you this, to talk about this, but would you guys call, I'm going to outline that, what would you call that? Just is it a crescent or a gibbous?
A crescent?
It is a crescent. Somebody once told me think crescent rolls for crescents. Yeah, it's a crescent. Yeah.
I was thinking of it behind something as
That's a waxing crescent?
I would call it a waxing crescent, exactly. Now this other bit around here, the reason I did this is called earth shine.
Yeah, for some reason
Okay,
It.
I thought it was an eclipse. Yeah, I was like, is that the moon, the dark part?
Now I have a picture of an eclipse coming up, but it's earth shine, so it's a crescent. But if you go ahead and set and so you just see it like that. But if you set your camera, it actually, and sometimes even without a camera, you can see a hint, the ghosty part of the moon. So what's happening is you should not be able to see that because the sun's rays aren't hitting that part. The only reason you see that is because there's still sun hitting the earth at some part, and that sunlight is going back up to the moon, and then it's bouncing off the moon. So it's actually light from the sun hitting the earth. Did I say that right? Light from the sun hitting the earth, and then going back up to the moon, and then coming back to us. That's earth shine. Yeah, I know. I like it. What else we got? Oh, there's earth shine again, and I got some pictures, or got some stars in that one.
That kind of looks ghostly
Yeah,
looking.
it does. Okay. Back to the slides. So this was a question you guys had to answer, and I think it was hard, okay, for you guys to answer. I know. I'll put this whole thing up here. So here's how this works. How long does it take for make sure I get this right, the moon to orbit the Earth? 29.5 days, exactly. The moon to orbit the Earth once is 29.5 days. Now, I told you also that the moon spins on its axis of rotation that same amount of time. This figure right here shows you, this gal is the moon, okay, and she's orbiting the Earth. If she did not spin, if the moon was rigid and did not spin, actually this is what it would look like, okay? And so I am the moon now, okay, and I'm not spinning, okay, but I am orbiting. Okay, we're going through the phases and all that, okay? 29.5 days, okay? But that's not what the moon does. The moon also spins. So now over here, this is synchronous rotation that I was talking about. Yay, that's good. So now I'm going to go ahead and take my 29.5 days to complete one orbit about the Earth, but I'm also going to spin. And I'm going to go ahead and and I heard you kind of call it it's like like gears, kind of. I'm going to be like in one tooth of the Earth. It's a gear thing. So as I orbit, I'm going to spin on my axis the same rate. So for instance, I'm going to start here. I'm going to go quarter of the way around, about a week, and notice that I have spun about a quarter. I'm going to go another quarter, okay, and I've spun actually, because I was facing this way and now I'm facing this way. So I've spun a half a circle, okay. I'm gonna go another one. Okay, go another one. Now, the deal is though, is the sun is out there doing its thing, okay? As I do this, actually all of me is getting sunlight, okay? All of me is getting sunlight.
No matter if you rotate or not.
Right. Yes, I think so.
You just
I
can't
I
see
think
it.
I need to rotate in order for
You
me all.
can't see the moon rotate though.
What's that?
You can't see the moon rotate though.
Right, you can't see the moon rotate. Actually, did you see, if I am the moon, you're only gonna see one side of me, yeah, and that's it, we only see one side. The side that you saw those photos of, that's the only side of the moon we're ever gonna see, unless we actually orbit the moon and take pictures of the. Sometimes they call this the dark side, but it's not really the dark side, it's the far side. I know, was it Pink Floyd you said? So this is the far side, this is the near side. The far side, I think I have a picture coming up. The far side is got its issues. Oh no, that's not the far side. The far side looks all pocked up. It's more cratered, and actually that's not an accident either. It's kind of taken the brunt of some of the early on bombardment stuff that went on.
Does it have much like the Earth? Does it? Like it's not, since it's not a planet like the Earth, does it not have its own, gravity and stuff? Like it's way different, so it doesn't get protected from this?
Okay,
No.
so,
what I'm saying?
yeah, I see what you're saying, and the Earth got bombarded a lot too. The reason that Earth's pockmarks are kind of covered up is because of weathering. So if we were to come visit the Earth, millions or billions of years ago, it would have been more pocked up than it is now. But the moon doesn't have the weathering because it's smaller and it doesn't have the gravity to have an atmosphere, so it doesn't have a, yeah. So this one, I won't show you all this, I think, because it might get old. But so one of the things, not just taking still images through my telescope again, is that I have software that just kind of works with the camera, and so you can take videos. And so, so you see that little belly, that I call it a belly button, but it's like we'll call it central peak. So you see the crater, and in the middle we call that a central peak, and that occurred like during impact. So there's no atmosphere on the moon, so what it looks like is kind of what it's been like for a long, long time.
But like, wouldn't the far side of the moon like naturally have more like craters and stuff because it's like towards the outside where like more things would hit it?
Yes, yep, it was towards the outside, more things would hit it, exactly. And you see the smooth part, we call those mare, and we call those highlands. I just think it is so cool. I mean,
How good is your telescope?
Oh, how good is the telescope? It's pretty good.
I mean, that looks really good to me.
That's what I thought, It's not the world's best telescope, and like I said, I'm getting a new focuser, so I'm excited. But you can kind of see the crater within a crater sometimes.
How big do you think those craters are?
That's what I started to say. I need to kind of get more of a perspective on how big they are. I think they're really big.
Because I'd like to see like a little person.
I know.
Like,
Okay.
could you imagine the clarity of like some of the bigger telescopes?
Exactly. Mine is, you asked how powerful it is. It's like, I want to say 6 inches. Okay, that's how big the lens is. So picture something a lot bigger.
So like the Whitty Observatory, would you see a lot?
The Whitty Observatory has a bigger,
Could you spot the
has a
flag
12 inch.
on the moon?
No, not even with the Whitty Observatory. We hear that a lot.
It'd be really funny if you could see somebody up there randomly.
It would, it would.
Astronauts.
Did you guys read, I don't know how long ago it was, but it said something about I don't know how they got these images, but you can see the footprint of the first astronauts, and they are undisturbed, like, it just is, it's still there. There's nothing to. Mhm. So I'll push those out there on Twitter. But yeah, I think they're kind of fun. And it's fun because you get to, if you're taking the pictures, you get to kind of, put it where you want to. I don't know the names of, like I should, the names of the craters and everything. I think that's on my list of things to do. There are apps out there that'll walk you through it. So a few more things we still need to talk about, and we've alluded to them. We got the whole eclipse things, okay? So we have a lunar eclipse and a solar eclipse. So I bet you guys are probably pretty good with this. If I make this the sun again, wait, yeah, is that what I did before? Okay, make that the sun, and I am the earth, and I'm holding out the moon, okay? If it's lined up just right, okay, if the moon's lined up just right, this is what, a new phase, right? Okay, then actually it will block out the disk of the sun, and they're about the same size, okay? So it'll kind of go, the moon will be orbiting the earth, and you'll see a bite taken out of the sun. That is so cool.
So
And
do we know, like, the sun and the moon, are they the same size?
they're the same, from our perspective, they what we say subtend or mark over the same amount of sky.
Okay.
Very similar anyway.
Okay.
Yeah. And then, so that is a solar eclipse. And then over here we have a lunar eclipse where, you know, the moon was like, it's in its full phase, and it's getting all the light from the sun, and basically what we say goes into the Earth's shadow. So the Earth is casting a shadow into outer space from the sun, and the moon goes into that. So romantic. Okay, that's called a lunar eclipse. So one of the things I'm going to test you over are these two things. When can they occur? And it's exactly what I've been saying. So hopefully you would tell me a solar eclipse can only occur, you know, they have to be lined up, but the phase has to be new, and a lunar eclipse, the phase needs to be full. That'll be a test question on there somewhere. So this actually, let's see, yeah. We talked, what is the plane of the ecliptic? What is the ecliptic? Do you guys remember? Yeah, that holds the sun in the Earth's orbit, exactly. That's the ecliptic. So that's kind of this blue-looking thing. And then what your author's done in this figure is to show the moon orbiting the Earth as little kind of at different places. So we don't have like 4 Earths, but kind of the Earth in 4 different places. And you can see that the moon is tilted out by about 5 degrees. So that's why it doesn't hit it just perfect every time. So I mentioned that in a lunar eclipse, the moon passes into the Earth's shadow. So that's kind of what's being shown here. The Earth's shadow is actually a bullseye and then kind of a lighter part. So the darker part is called the umbral part of the Earth's shadow, and the lighter part of the Earth's shadow is called the penumbra. Now, was it in February? It's coming up. I think I put it on your list of things you can do. There is a lunar eclipse, but it's a penumbral lunar eclipse. So the moon is going to be passing through the penumbral part of the Earth's shadow, and it's a very, very subtle thing. So, no, this is just the Earth's shadow.
Oh.
Yeah, they're not showing the moon here.
So will it just look like there's like a little blanket over it, kind of?
Yeah. So for that one, it's just going to kind of go right here. Here will be the moon. It will look normal. And then you'll see, I don't even know if you'll see a bite taken out of it. But here it will start to pass in the weak part of the Earth's shadow. And then it will actually kind of pass out of the weak part of the Earth's shadow over there. It'll be kind of a blanket over it. Mm-hmm. Okay. Well, why don't we, I have just a few slides. We didn't get through everything, but we did pretty good. I'm going to start here on eclipses on Wednesday. Okay, and then for sure we'll talk about the wandering planets. So Wednesday we're going to start in on the, chapter 3 to me is kind of like the history of astronomy. It's kind of fun. So we'll start in on chapter 3 on Wednesday too, okay? All right.